As we all know, this is the era of drone warfare, and Russia's strategy has been evolving. They have started using fiber-optic drones due to the increasing use of electronic warfare by the Ukrainian Army. In short, these are invincible to radar or radio. Let's look at their drones and their various purposes. Orlan drones are launched for surveillance and can penetrate nearly 600 kilometers into a country. The second type of drones are FPV, guided by fiber-optic cables. These have a range of only 1 kilometer or about 1.2 miles. Standard FPV or first-person view drones, on the other hand, have a range of 10 kilometers or roughly 5 miles and more. Next are the Lancet drones. These are advanced main battle tank killers capable of flying for 40 kilometers or about 24 miles. Finally, there are the Iranian Shahed drones, which can travel up to 1,000 kilometers or approximately 620 miles. These drones can cause significant damage when launched in large numbers. More details all in the video ahead. This is Russia's latest upgraded FPV drone equipped with a fiber-optic cable at the back. This modification is necessary because Ukrainian forces are using radio signal jamming on the battlefield, making it essential to maintain a stable connection with the operator to ensure the drone reaches its target. At the front of the drone is a camera with an RPG warhead positioned just below it. The warhead is flanked by 2 batteries located here and 4 propellers. However, the drone has a downside. The added weight with the fiber optic reduces its flight time to just 15 to 20 minutes, and its range is limited to only 1 mile or less. This, when compared to a standard drone without fiber optic, it travels more than 5 miles, which translates to around 10 kilometers. In the era of drone warfare, Russia's strategy unfolds through a series of coordinated stages, each designed to maximize the effectiveness of their aerial assets. Stage 1. Surveillance and target acquisition. The first stage involves the use of Orlan drones for surveillance. These drones are critical in scanning the battlefield for Ukrainian targets, serving as the tip of the spear in the process of identifying and selection. Stage 2. Precision strikes with Lancet drones. Once targets such as Ukrainian tanks or Gepard anti-aircraft guns are identified, the next step is to launch Lancet drones. These drones are deployed to destroy or severely damage the identified targets with precision. Before we examine how it works, let's look at its parts. Although the Lancet can be operated by a 2-man crew, but behind the scene it has a number of parts that helps it to operate in the battlefield. Number 1. It requires a catapult to launch a drone. Number 2. An Orlan drone that is responsible for navigation and observation for the Lancet. Number 3. A command and control center is required to operate the Orlan as well as the Lancet drone, as data regarding the Lancet drone are still classified. Let's take a look at the parts as a possible theory. Again, I repeat, this is a possible theory of the engineering behind the drone. At the front of the drone is the electro-optical guidance systems. These cameras act as a light contrasting edge of the target, dark or light, against the general background, to track and guide itself. In short, it acts as a guidance mechanism. Just behind the guidance system is the warhead. It is the typical KZ-6, a high-explosive circular-shaped charge used for demolition, primarily to penetrate armor and reinforced concrete fortifications. Moving to the back is the electric-powered engine that propels the drone to the standard speed of 110 kilometers per hour or 68 miles per hour. Interestingly, this drone can operate only for 40 minutes, almost similar to the Switchblade 600. These are the step-by-step process of how this works. Step number 1. 2 soldiers launch a surveillance drone named Orlan using a catapult system. Step number 2. The Orlan drone tracks and selects targets. Step number 3. A soldier unfolds the Lancet drone wings and sets it up for catapult launch. Step number 4. The Orlan command and control system transfer data target to the Lancet drone. Step number 5. The Lancet drone switches to its electro-optical guidance systems as directed by the Orlan command and control center. Step number 6. The Lancet drone will dive into the target and activate the typical KZ-6, a high-explosive circular-shaped charge used for demolition, primarily to penetrate armor and reinforced concrete fortifications. Let's simplify again through these animations. The Orlan command and control system transfers target data to the Lancet drone. The Lancet switches to its electro-optical guidance systems to track its target. It then descends upon the target using its KZ explosives to penetrate light armor, artillery, guns, or trucks. Stage 3. Saturation attacks with Shahed drones. In the third stage, Russia employs low-cost Iranian Shahed drones, which are launched in large numbers, sometimes up to 200 at a time. The affordability of these drones allows for mass deployment, overwhelming Ukrainian defenses, and increasing the likelihood of successful strikes. The sheer volume of Shahed drones in the air serves to saturate the battlefield, making it difficult for Ukrainian forces to counter all of them. While this drone has a different name in Russia, and it's called Jiran 2. While the Islamic Republic of Iran unofficial name is Shahed 136. There are slight differences and upgrades between the two. The Iranian Shahed 136 uses an inertial navigation system which cannot be jammed by radio frequency interference. However, it has its disadvantages. Its real-time position data is less reliable than that of GPS. Once released, it is difficult to track or command. The Russians upgraded these drones with GLONASS, a Russian alternative to GPS. The advantage of this upgrade is that the drone can loiter and hit its targets when GLONASS or GPS data is linked in real time. However, the disadvantage is that it can be jammed by bombarding it with radio frequency interference, which could cause the drone to crash. The reason they are using these drones is because of the cost factor. This Russian cruise missile cost $1 million. The American cruise missile costs about $2 million, while the Shahed 136 is essentially a low-budget cruise missile with a reported price tag of just $10,000 to $30,000, depending on the variant. To put that in perspective, the average price of a car in America is around $40,000. The drone is carried on a simple truck carrier that looks like it is carrying cargo. In this standard truck, they can carry as much as 5 drones stacked against each other. At a press of a button, the drone is launched with a rocket-assisted takeoff. This rocket-assisted takeoff is ejected just like this visualization here. This was installed to reduce weight and efficiency and let the 2-stroke engine take over. Stage 4. Support from civilian drones. Accompanying the more sophisticated drones, civilian models such as Mavic 3 drones are utilized in the 4th stage. These drones provide additional reconnaissance and support, offering real-time situational awareness and aiding in the coordination of strikes. This allows for Stage 5, where high-impact strikes with cruise missiles takes place. The final stage of Russia's strategy involves the launch of cruise missiles. These missiles can be launched from the Tu-pole of Tu-95, Tu-160, or Tu-22. But just a reminder, these high-value aircrafts will not move deep into Ukraine due to the presence of Ukrainian fighters jets like the F-16 and Soviet-era fighter jets. These high-impact weapons are used to deliver devastating blows to strategic targets, often as a follow-up to drone attacks. These aircrafts will launch these cruise missiles from a safe distance and return back to Russia. The precision and power of these missiles ensure that key objectives are destroyed, effectively rounding out the multi-layered approach of Russia's drone warfare strategy. But these drones do have their drawbacks due to their slow speed. One such incident occurred when an onboard gunner of a Mi-8 helicopter from Army Aviation shot down a Russian Shahed 136 attack drone. When the helicopter and the Shahed drone were at a similar speed, a turret gunner, using a Mag 7.62mm machine gun, started firing in its direction. This short burst of fire at its engine put it out of the sky. We also make original engineering content, so please subscribe and hit the notification bell for more videos.